So the next question says, a chemical reaction for the production of the drug aspirin from two compounds X and Y is represented in the balanced equation. So we've got X, compound X, which is C7H6O3, plus compound Y, which is C4H6O3, gives us aspirin, which is C9H8O plus some water. O it's 4 plus. It says the chemist reacts 14 grams of compound X with 10 grams of compound Y. And the first thing it says, define the term limiting reagent. So grade 11s, as I've stipulated several times with you guys before, the most important thing that you need to do is make sure that you've learned all the definitions from the textbook, okay? All the definitions. So now what we are going to do is we are going to just tell you what the understanding of the limiting reactant is, which is that it is the reactant that is used up first. It is the reactant that's used up first, and it controls how much product is made. Okay, it controls how much product is made. Right, so now let's look. It says perform the necessary calculations to determine which of the compounds X or Y is the limiting reactant. Okay, so the first thing that we need to do is we actually need to work out the number of moles that we're given of each. So to do that, we need the molar mass. So we're going to first find out the molar mass of X. So that is made up of 7 carbons plus 6 hydrogens plus 3 oxygens. So it's going to be 7 times 12 plus 6 times 1 plus 3 times 16. Okay, so now if we look at that, we can see that that is 7 times 12 is 84. Plus 6 plus 3 times 16 is 48, which is going to be 90 plus 48, which is 138 grams per mole. 138 grams per mole. So now we can work out the number of moles. So the number of moles of X is mass over the molar mass, which is 14 divided by 138, which is going to be what? It's 14 divided by 138 equals, and press the SC button, 0.101. So it's 0.1, 0.1 moles. Okay, so we've got 0.1 moles of X, okay? Now let's do the same thing, but let's do it for Y. The number of moles given versus the number of moles in our calculation. So we're going to do Y. And Y is made up of 4 carbons plus 6 hydrogens plus 3 oxygens again. So this is 12 plus times by 4 plus 6 times by 1 plus 3 times by 16. 4 12s are 48. Plus 6 plus 48. So that is 96 plus 6, which is 112. 112 grams per mole. So therefore the number of moles, again, is the mass, which is 10, divided by the molar mass of 112. So it's going to be 10 divided by 112. Is going to be 0.09. So this is 0.09 moles. Okay, so now let's have a look at this. The ratio is 2 of X needs 1 of Y. Okay, so in other words, if I've got 1 mole of Y, I need double the amount of X. Okay, do you agree? So if we look at this 0.09, 0.09, if I multiply it by 2, do you agree that that gives me 0.18, which is more than what I've got. So therefore, Y is not my limiting reagent. X is my limiting reagent. X is my limiting reagent because for every 0.1 moles of X, I only need 0.05 moles of Y. So once I've used up X, okay, I'll still have some Y left over. So therefore, my limiting reagent is X. Okay, compound X is my limiting reagent. Right, now it says the actual mass of aspirin obtained is 11.5 grams. Calculate the percentage yield of the aspirin. Okay, so what we need to do is work out theoretically what we should have got if we use up all our 0.1 moles of X. So that's what we need to do first. We need to look at the number of moles that we've got, how many we used up, how many should have been used up. So do you agree that this is our limiting reagent? So now we need to use that to see how many grams of aspirin should have been formed. Okay, so the theory goes that 2 moles of okay, we'll call it X, gives us 2 moles of aspirin. Okay, but we don't have 2 moles, we've got 0.1 moles. So 0.1 moles of the aspirin should give you 0.1 mole, of X, give me 0.1 moles of the aspirin. Okay, right, so we now know that number of moles is mass over molar mass. The number of moles is 0.1. The molar mass we need to work out. So let's do that. We've got 9 carbons plus 8 hydrogens plus 4 oxygens. So 9 times by 12 plus 8 plus 4 times by 16. Okay, so now let's go through this. 9 times 12 is 108. Plus 8 plus 4 6s are 24, carry to 64. So that becomes 116 plus 64, which is 4 and 6, that becomes 180 grams per mole. So therefore we can work out the mass. We can go 0.1 times by 180 is equal to the mass, which is obviously going to be 18 grams. So therefore, theoretically, we should have got out 18 grams, but we only got out 11.5. Therefore, our percentage yield is going to be 11.5 divided by 18 times by 100 over 1, because it's always a percent, divided by 18 equals. So do you agree that's 0.64? So that is 0.64 multiplied by 100, which is going to give me 64%, which isn't a bad percentage yield, but it isn't the best either. Not a bad percentage yield at all.